Hello, today we're going to learn about going from word equations to a balanced chemical equation, which means that we're going to be writing our formulas like we did in our last chapter of Chemistry A. And we need to make sure we do that correctly, and then we will balance the equations like we have been doing. Okay, this is on page 4. We're going to go over 6, 7, 8, and 9. So let's go ahead and review what we know about the periodic table. Please remember your charges. If it's group 1, plus 1 charge, group 2, plus 2 charge, plus 3 is group 13. This is because these are metals, and metals want to lose electrons to become more stable. That's why they have positive charges. Then we have some negative charges, and that's with the nonmetals, because nonmetals want to gain. So group 15, negative 3 down to here, negative 2, negative 1, and then of course our noble gases are just a 0. And all these guys in the middle, okay, and even down here, they have variable positive charges, and so we need to make sure that we use Roman numerals. There are 2 exceptions to this, zinc and silver. Remember that zinc is a +2 and silver is a +1. Okay, those are your charges from our last unit. Okay, let's go ahead and get started with number 6. So number 6 says sodium reacts with water to produce sodium hydroxide and hydrogen gas. So the first thing I like to do is I like to underline all of my elements, and I also like to look for keywords like and assign plus signs and arrow signs. So right here we've got sodium. Reacts with means plus. Then water is a compound. To produce, that means arrow right here, to produce. And we've got sodium hydroxide, and means plus. Then hydrogen gas is another formula. Okay, so now that we have that, let's go ahead and let's write out our formulas. So sodium. Sodium is Na. Now you have to remember here, Brinkelhoff. So whenever you have elements that are by themselves, if it's one of these 7 diatomics, you have to write them with a 2. So sodium's in group 1. It's not a diatomic molecule. It's not a Brinkelhoff, so we're just going to leave it as sodium, as Na. Reacts with, that's our plus sign. Water is just H2O. To produce is our arrow. Then we have sodium hydroxide. So sodium, Na. Now, because this is an ionic compound, we need to look at charges. So we've got sodium. Sodium is in group 1, so it's a +1 charge. And hydroxide is a polyatomic ion. So you have OH with a -1 charge. And just to make sure that you guys realize that on the front of your packet, you have a list of the polyatomic ions again. So make sure that you are familiar with those. So because our charges cancel, we don't need to worry about any subscripts. Okay, the word and means plus, and then hydrogen gas. So this is just giving us more information. We don't need to worry about the fact that this is a gas, but we do need to worry about hydrogen. And because it's alone, you got to ask yourself, is it a diatomic? Is it one of these 7 Brinkelhoffs? And it is. It's right there. It's hydrogen. So we got to put a 2 down below. Okay, now that we have correctly written our formulas, now we balance. Okay, and I'm going to kind of go a little faster on balancing. I'm not going to write out charts, but if you want to write a chart out, do it. Okay, so on here we have 1 sodium, so that looks lovely. Then we're going to do our hydrogen next. We've got 2 hydrogens, and here we have 1, 2, 3 hydrogens on the side. Okay, I call this one the control because we've got hydrogens in 2 locations on the product side, but we only have it in 1 location over here. So we know that 1 doesn't work because it's already being represented. 1 as far as the coefficient goes, like right there. We don't ever put 1, but it doesn't work. So what we're going to do is only go up by 1. So because we know that 1 doesn't work, we're going to try a 2. So right now we have 2 times 2, which makes 4. Is there anything we can do here to make 4? Well, we could put a 2 right here because then that gives us 2 times the 1 plus 2 equals 4. So that would work. Let's go ahead and do that. Now, if this didn't work, you would up this 2 by 3. If that didn't work, you'd up it by 4. If that didn't work, you'd up it by 5. Another thing to note is that when we're adding a coefficient to this water, it's also affecting the oxygen. And notice over here, the oxygen is only in one location. It's right there. So whatever we do here, as far as our coefficient, we have to do the same here because our oxygen. So it's kind of like a little trick of the trade. All right, now let's look at our oxygen. Our oxygen, we've got 2 right here because that's going to distribute. And here we have 2 because that distributes. Okay, I think we're balanced, but let's double check. Oh, nope, we're not. So see how sodium, we went from 1, and here we have 2. So we got to put a 2 here. This is why we double check. So we got 2 sodiums, 4 hydrogens. 2 times 1 is 2, plus 2 is 4. Oxygens, we've got 2, we've got 2. So now this is balanced. So again, what we're doing is going from a word equation. This is our word equation right here. To a formula equation. That's what this is. This is called formula equation. And once we balance it, then it's called a balanced chemical equation, or sometimes people don't say balance, they just say chemical, because they're assuming that you know that chemical means that it's a balanced equation. Okay, let's do another one. Let's do number 7. Okay, again, let's underline as we read through this. Underline substances and words that make plus signs and arrows. So we've got chlorine gas. And means plus sign. Sodium, metal. Reactive form, this means arrow. Sodium chloride. Okay, so now we're going to do chlorine. Is chlorine a diatomic? Brinkelhoff, yes it is. We're going to have Cl2 plus sodium. Okay, it's just giving us extra information about the fact that it's a metal. Reactive form, and we've got sodium chloride. So since this is an ionic compound, we have to look at charges again. The sodium, it's in group 1, so it's a +1. Chloride is Cl. It's chlorine, but because it's in a compound, we're changing the ending to "ide." This is in group 17, so it has a -1 charge. And now our charges cancel, so we're just left with NaCl. Okay, let's go ahead and balance this now. So when we balance this, we've got 2 chlorines, only 1 here, so we're going to put a 2 in the front, because remember, when we balance, we can only use coefficients. Now we've got 1 sodium, 2 right here, so we're going to put a 2 right there. Okay, let's double check. So 2 chlorines, 2 chlorines, 2 sodiums, 2 sodiums. So now we have our balanced chemical equation. Okay, let's go ahead and do number 8 now. So here we are on number 8. Oop. Okay, so this one we have copper. Combining with means a plus sign. Combining with. Sulfur, to form means arrow, and then we have our product, which is copper, Roman numeral 1 sulfide. So let's go ahead and write this out. So when we write this out, we've got copper. Copper is Cu. Okay, it's by itself, so is it a diatomic? Is it a Brinkelhoff? And the answer is no, so we're going to leave it alone. Combining with means plus sign. Sulfur, again, ask yourself, is it a diatomic? Nope, it's not, so leave it alone. To form is your arrow. And then we've got copper 1 sulfide. So copper is Cu. Remember that this Roman numeral tells us that it's a +1 charge. Roman numerals always go with the metal, and they're always positively charged. And then sulfide is S, and sulfide is in group 16, so it has a -2 charge. Okay, these charges don't cancel, so we're going to swap and drop. So how that really looks is Cu2S. Okay, hopefully everyone is okay with that. All right, now it's time for balancing. So right here we have 1 copper, 2 coppers. So we're going to go ahead and put a 2 there in the front. And now we have 1 sulfur and 1 sulfur. So I think we're balanced, but let's double check. 2 coppers, 1 sulfur, 1 sulfur. Fantastic. Okay, there's your balanced chemical equation right there. Okay, let's do number 9. So number 9, let's go ahead and read through this. Okay, this one we have silver nitrate. Reacts with means, you've got it, a plus sign. Sulfuric acid. And notice that this is something we haven't talked about, so I'm giving you the formula right after the name. To produce means arrow. Then we have silver sulfate. And means plus sign, hydrogen nitrate. Okay, so let's go ahead and write this one out. So silver nitrate, we've got Ag. Okay, silver is a metal, so look on your periodic table. Silver always has a +1 charge. That's one thing you need to memorize. Then we've got nitrate. It ends in 8, so automatically I want you thinking polyatomic ion. So nitrate is NO3 with a -1 charge. And here your charges are just going to cancel. Reacts with means plus sign. Okay, sulfuric acid. I'm giving you the formula here because we have not talked about how to name acids yet. So just write down H2SO4. To produce, there's your arrow. Okay, silver sulfate. Again, this is an ionic compound, so we have to look at charges. So silver, once again, is a +1 charge. Sulfate, oh, polyatomic ion. This is SO4. The -2 charge. These charges don't cancel, so we're going to have to swap and drop. So when we do that, that 2 is going to come down, okay, right there behind the sulfur. Let's change that color a little bit. And then that 1 isn't going to do anything. But remember, with polyatomic ions, we always keep our subscript. So because 4 is part of sulfate, we always keep that. That is a interesting arrow I just made there. Okay. And means a plus sign. And then hydrogen nitrate. So again, look at charges. Hydrogen, it's in group 1, so it's a +1 charge. Nitrate is a polyatomic ion. It's NO3 with a -1 charge. Here our charges cancel. Okay. All right, so now we've got this equation. I'm going to erase some things just to make things look a little bit better. Okay. All right, now we're going to go ahead and balance. So I'm just going to start from left to right, leaving hydrogen and oxygen until the very, very end. Okay, right here we've got 1 silver, 2 silvers. So we're going to go ahead and put a 2 right there in the front. Okay, now we've got 2 nitrogen, because that 2, that coefficient, is going to go to everything behind it. So we've got 2 nitrogen. Here we have 1, so we're going to have to put a 2 in the front of that hydrogen nitrate. Then we're going to look at sulfur. Notice how I skipped over the oxygen and the hydrogen because we do those last. So sulfur right here, we've got 1. And if you can't tell, just isolate sulfur. Just look at just the sulfur. Notice there's nothing behind it. So that means no coefficient, no subscript. Okay, and then right here, we've got 1. So again, look at what's around the sulfur to the right. Okay, so that means that that is balanced now. As far as the sulfurs go, they're balanced. Okay, sorry, I'll kind of erase that. Okay, let me rewrite that. There we go. Okay, now let's go back and do hydrogen next. So hydrogen, we've got 2 here, and we've got 2 here, so that looks lovely. And now let's do our oxygen. Oxygen here we have in 2 places. We've got a 3 here, but times 2, so we have 6 there, plus 4. So on this reactant side, we have 10. And then on this side, we've got 4. And then 2 times 3 is 6, so a total of 10 on that side. Okay, I think we're balanced, but let's just double check. 2 silvers, 2 silvers, 2 nitrogen, 2 nitrogen, 6 plus 4 oxygen is 10. Over here, 4 oxygen plus 2 times 3 oxygen is 6 equals 10. Hydrogen, we have 2 here. We got 2 right here. Sulfur, we have 1. Sulfur, we have 1. Okay, that one is now balanced.